Hi everyone. So this lecture that I'm recording now is an extra one. I've already sent out a message about doing a WebEx lesson for Friday morning. I'm recording this on Thursday. I'll be putting it up anyway because I think it covers some important stuff, and we're just going to be having a WebEx just to test that we can all get access to stuff online. So that's still going ahead on Friday morning at 9:40. Make sure you're clicking the link that I sent you. But generally, just wanted to cover some of the things that we'll be doing as we go into the holidays. Now, we are starting holidays a week early. We don't have week 10. Despite that, I am basically going to be using week 10 to go through a whole bunch of revision of everything we've been doing in the first term so far. So that's going to include some revision of trigonometry, some of our basic linear stuff, and also quadratics, cubics, polynomials, all that kind of stuff that we've been doing for the duration of the term. So without further ado, let's get going. Just so we're aware, I have made study material available to you over the holidays in the library tab of Connect. So if we go to Connect itself, it's the library tab, and we've got a whole bunch there. There are revision chapters from the Alternative Mathematics Methods textbook. And if we go into, that will be in supplementary problems. So if you go to the supplementary problems folder, then you'll be able to find those ones. MathSpace activities, that's at mathspace.co, and you should be able to find the code to connect up to that. In the notices, I sent a few emails out about that, a few notifications. So one thing to know is that many of the MathSpace problems are quite hard. Some of you will have found them quite difficult, and they are. Don't be afraid to use hints or get the next steps or anything like that, but they're definitely very good practice. And we've also got an assessment. So this assessment is quite important. It is based on the 2019 exam. I've literally just taken questions out of the 2019 exam. This is going to be due Friday of week 1 next term. You can get that in practice assignments in the library tab. I've also put it in the content tab there, and you can check that to see where the practice assignment is there. This is worth 1% of your grade. 1%. And I know that's not much, but it is excellent preparation for the exam. It is literally last year's exam. I've taken about a third to a half of the questions out of last year's exam, turned them into an assessment that I'd like you to complete. Now, this will definitely really prepare you very well for the exam itself, so make sure you're getting that done. So that will be something that you can do in week 10 or over the holidays. Now for this, you are more than welcome to ask me for help, work with each other. I don't expect everyone to do this on their own. So there will be opportunities for you to ask me for help, either in WebEx or WebEx sort of lectures, or otherwise just email me, ask for a bit of help, something like that. I may end up doing a video if there's a lot of requests for any particular thing to solve. But all the same, that's how we can get access to some of our stuff that we need over the holidays. Now, there is an important idea we need to have a quick little look at, and that is the idea of factorizing cubics. So when we factorize something, we turn it from being in the form ax, so let's say we're factorizing a quadratic. It will be ax squared plus bx plus c, and we will be factorizing it into the form x take, or we'd have an a at the front, x take, I don't know, m, I forget exactly what things I did, x take n, and this would tell us, and let's say that was y, and what this would tell us when we factorize it is it tells us where the x-intercepts are. So the x-intercepts would be at m and n. Now we can do the same thing in when we're looking at cubics as well. We don't just have to, we can do the same sort of thing, and it follows the same sort of practice as we do when we're looking at quadratics, but there's a bit of a complicated step in there as well. So cubics can take this form, ax cubed plus bx squared plus cx plus d, or they can take this form like that, a brackets x minus p, x minus q, x minus r. So a few things that we can find about our equation. If we want to find the y-intercept, if it's in the first form, that'll just be d. So whatever this d is, everything else gets zeroed out. This is going to give us the y-intercept. Likewise, if we've got a cubic in the second form, we can find the x-intercepts, and the x-intercepts are going to be p, q, and r. Note that we've got a subtract for all of these. So if we happen to have x plus 3 inside one of these, that the x-intercept will be at -3, not +3. So that's just something to be aware of when we go through these. So, and basically, the upshot of this is if we know one of our x-intercepts, that is when y equals 0, we also know one of our values of p, q, or r. So we know one of the up to 3 x-intercepts that will happen in a cubic. So we may be able to factorize the equation to find the other 2 intercepts. Now there may only be 1, 2, or 3 intercepts in a cubic. There doesn't have to be 3 every single time. There can just be 1 or 2 intercepts. But if we can factorize it, then we can prove that it's got up to 3 different intercepts. So there are 2 ways to go about doing this. We can use algebra and reasoning to determine the solution, or we can attempt long division of the equation. Now, I am going to showcase both of these methods. You're welcome to use whichever one makes more sense to you. The algebra and reasoning method I quite like because, well, it makes sense to me. The long division one, it works, but it's a fairly complex algorithm that, that is easy to make mistakes with, but some people like to use it. But I'll be showing both methods as we do it. So, this is question 5B from the 2018 exam. You can get access to that online, so you should be able to see that. But I'm going to be having a look at this equation here. Now, the way that they've worded it is a bit fancy. They've said one solution to this equation is x equals 2. If one solution to this equation is x equals 2, that means it's going to have a factor of x minus 2 in there somewhere. But we've got to rearrange this equation so all our cubics are on one side and we've got equals 0. So all of the elements of our cubic are on one side, it all equals 0. So let's have a look. We've got an equal sign in the middle. So what we've got to do is rearrange it first. So that's going to be x cubed. Let's take our x squared term over. That'll become subtract 5x squared. We've got our 12x term there. That'll become subtract 12x because I'm moving both of these onto the other side of our equation. And then got plus 36 equals 0. Normally this would be equals y if we were graphing a function, but we've got equals 0 here for the time being. And with the equals 0 there, basically we're finding the x-intercepts of this one. And we've gotten one x-intercept already, it's x equals 2. That means that the whole thing is going to be able to be factorized into x minus 2 multiplied by some quadratic, which will be ax squared plus bx plus c. Now, I'm doing the algebra and reasoning version on this side. On the other side, I'll do the long division version. So just on this side, we're going to be doing the algebra and reasoning to determine our solution. So we're trying to find a way, we're trying to find what A, B, and C are in this equation, so that when we multiply this on this left side by that on the right side, we end up with this equation. This times what numbers in here end up with that equation on there. And we can actually work that out by having a look at our x cubed term, or just our different terms. We've got our x cubed term, we've got our x, or the x squared term, that's the coefficient of negative 5x. We've got an x term, and we've got a unitless term, or basically it's not being multiplied by x, it's got x to the power of 0 effectively, but our constant term in there. So how do we get out of this equation, what is the only way to get x cubed? The only way to get x cubed is to multiply that x by that x squared. So when we multiply x by ax squared, we get ax cubed. And we know that that is going to be equal to x cubed, because when we multiply this all out, we end up with this top equation here. So ax cubed is equal to x cubed. So what's a? A equals 1. Pretty straightforward for this one. A is the A part is the easiest one to get. The next easiest part is actually the C part, because, and I'm just going to look at this. If we do, the only way we can get this constant over here is by doing negative 2 times C, because everything else is going to have an x in it. So we got negative 2C equals 36. So what's C going to be? Divide it by negative 2. C is negative 18. So that is taking our constant terms there, and that will end up being C is negative 18. Now we've got to find B. B is the hardest one to find. I'm going to be doing it by looking at this term here. So what we've got, remember that this is a quadratic, or this is a bracket expansion. We've got to find out what are all the ways to get x squared in our equation. We can get x squared by doing, and I'll do this in, what color shall I'll choose purple for the moment. So I can get x squared by multiplying negative 2 times ax squared, and that will have an x squared there. So that'll be negative 2 ax squared. The other way I can get an x squared term is by doing x times bx. And when we expand these will be combined together as like terms. And whatever they end up with, they will add to negative 5x squared. Now we've got x squared terms in all of these, so we can cancel all of those out. So negative 2a, and we know what a is as well. A is 1, so 1 times that doesn't change it. So we've got negative 2 plus b. In fact, let me just give us a bit more vertical space here, because that does take up. There we are. Negative 2 plus b equals negative 5. So what's b going to be? B is equal to negative 3. There we are. So we have gotten an equation, and the reason I crossed out the a is because I knew this a was equal to 1. 1 times anything doesn't change our number, that's why I crossed it out. So we've got negative 2 plus b equals negative 5. We could also, if we really wanted to, we could have worked it out using this negative 12 by doing negative 2 times bx equals x times c, negative 2 times bx plus x times c is equal to negative 12, but that is a much more complicated equation. And in fact, I may as well do it now. So we don't have to do this. This is just confirming that are suspicions that we've got the right number. X times C, so CX. Negative 2 times B, so take 2bx equals negative 12. There's x in all of them. We can divide both sides by x to get rid of it. C, we know, is negative 18. Take 2b equals negative 12. Add 18 both sides. Negative 2b equals 6. B is negative 3. So the fact that I've gotten B is negative 3 both ways means that I can be fairly confident that B is in fact negative 3. Okay, so what that means, and I'm going to write my answer over here, what that means is that if I was to factorize it, it would be x minus 2, and a is 1, so it would be x squared take 3x, because b is negative 3, and c is 18, take 18. Now what we need to do is factorize this equation on the right here. What two numbers multiply to negative 18 and add to negative 3? Have a bit of a think about that, but it ends up being x take 6 and x plus 3. Remember that the final thing we're trying to find is when this is equal to 0. So when's this equal to 0? X equals 2, 6, or negative 3. So that is our final answer. X is 2, 6, or negative 3. So that is how we can, and it's a bit of a process. This is how we can use logic to work out what our solutions are to this equation up here. Remember, I rearranged it so it was all equal to 0, and then worked out what A, B, and C had to be in this form. Factorized that using all of what we already know about factorizing quadratics, and then we worked out what solutions give us an answer of 0. So I'm going to go on the long division method. Now, some of you may not exactly remember long division, but it's basically a procedure, and it works with these polynomials as well, which is quite interesting that it does actually work. But what I need to do is I need to get this equation. I've got x cubed, take 5x squared, take 12x plus 36 in here. And I know that x minus 2 is going to be a solution or a factor to this. So I'm trying to take x minus 2 out of that. Now, what times x minus 2 allows us to negate, or it makes it equal to this x cubed? If I multiply x minus 2 times x squared, I end up with x cubed minus 2x squared. And so what I want to do here is I want to, and you may want to look up a video on how to do original or classical long division, but basically what I want to do is if I multiply this by these two together, I want to subtract off what I get here. So subtracting x cubed gives me negative x cubed. Subtracting 2x squared ends up with plus 2x squared. So let's do this. X cubed minus x cubed is 0, which is what we expect. We expect to start cancelling these out. Negative 5x plus 2x is negative 3x squared for both of those. Now with long division, we always bring down our next one. And now what we want to do is find what do we multiply this by to make it equal, to give a negative 3x squared term. So that's going to be, is this coefficient right here, it's negative 3, but to get x up to x squared, we've got to multiply it by x. So if I was to do negative 3 x minus 2, that will be negative 3, oops, not negative 3, just that. That's supposed to be negative 3x. That's going to be negative 3x squared plus 6x. I want to subtract this off, so that's going to be plus 6x, or sorry, plus 3x squared, and that plus, that one subtracted off is going to be minus 6x. So we end up with negative 18x plus 36. What do we need to do to cancel out this negative 18? We need to multiply it by negative 18. So negative 18 times x minus 2, that is negative 18x plus 36. And you can see that this number is exactly the same. And so we got, if I was to subtract that off, we'd end up with 0. So it would be plus 18x take 36, and that equals 0. Then we're left with nothing, so which is exactly what we want here. So that means that this is my factorized, or this is my, after I factorize it, taking the x minus 2 out, I'm left with that, and that is exactly the same as the answer I got down here. So x squared minus 3x minus 18. Now, I can absolutely promise you right now, there will be a question where you have to do this in whichever form you choose to do it in the exam. You must be able to do this. It is a really important thing to be able to do. And there are a number of exam questions that do go through, or that are these kinds of questions in the past exams. And I strongly recommend going through those and having a look at them. So, just to finish off for today's lesson, we're going to have a look at the calculator free section of the 2018 exam. We should be able to answer almost all of these questions in here. So I'm just going to quickly go through these. I strongly encourage you to make sure you are trying these before I show you the answers. Basically, I do recommend you do that instead of just being shown what the answers are. But we'll have a look at this one first. It's 9 marks in total. What are the coordinates of the y-axis intercept of this line? So this is a linear equation. So what we want to do here is to change it into the form y equals mx plus c in some way, and that means we need to get y on its own. How do we do that? We add 11 to both sides and we subtract 3x from both sides. We end up with 5y equals negative 3x plus 11. But we haven't gotten y on its own yet, so we need to divide both sides by y. Negative 3x on 5 plus 11 on 5. The y-axis intercept will be when x equals 0, so it's just going to be 11 on 5. It's the coordinates we want, so we want to basically say that the x is not changing. We know x is equal to 0. That means that the coordinates will be 0 and 11 on 5. Pretty straightforward. Next up, a quadratic function is given by this equation. What's the y-axis intercept? That occurs when x is equal to 0. So that's just going to be y equals negative 1 times 4, which is negative 4. But remember, we're after coordinates, so the y-axis intercept is when x is 0. So that's going to be 0 and negative 4. Pretty straightforward. Where are the zeros? Or when it says zeros, it actually means x-intercepts. Another word you might see for these is the word root. They can call it a root, a zero, or an x-intercept. You have to understand that all those mean the same thing for what we happen to be doing. So if we want to find that, we can have a look. And here it's all going to be 0 when x equals 1 or x equals negative 4. So that's just the x points though, so it's asking for coordinates. We need to make sure we write 1, 0 and negative 4, 0. What's the equation of the axis of symmetry? It's going to be a vertical line that goes halfway between the two x-intercepts. So I like to do 1 plus, I like to add them together and divide by 2. That gives us -3 on 2. And remember that this is just going to be, and it's often good to draw a little diagram here. We've got our x-intercepts of 1 and -4. Remember that this is a symmetrical parabola. We expect it to go roughly through that point. So this is the equation x equals -3 on 2. And that looks about right based on what we've got there. What are the coordinates of the turning point? Well, we know that the line of symmetry is x equals -3 on 2. That's the x coordinate of what we've got there. So let's look back. Y equals -3 on 2. What is it? Take 1 and then plus 4. -3 on 2 plus 4. -3 on 2 take 1 is -5 on 2. -3 on 2 plus 4 is, these are being multiplied. So that's 1.5 plus 4, that is 2.5 again, so that's going to be 5 on 2. Multiply these together, you get -25 on 4. So our coordinates are going to be -3 on 2, -25 on 4. Or if you wanted to do that, it's -6.25 is what that actually ends up being. Now I can test this. This is not a calculator-free. This is a calculator-free section, but I can still have a look and just make sure that I've got what I've got on the coordinates of the turning point. Oh yeah, I've written those there. So we've got x minus 1, x plus 4. Let's graph that. I don't need to do y equals. There we go. -4, 1. Where's that? I can go analysis, G-solve, find our minimum. That is as expected. -1.5 and -6.25 or 6.25, which is pretty much what I expected there. So let's look there. So let's get that back up. So yeah, -1.5, -6.25 as I worked out there. So -3 on 2 is -1.5. And -25 on 4 is -6.25 there. Okay, so that's that one. So we now have a relation. This is y squared equals x. And just to remind you what this relation, oops, don't want that one. Just to remind you what this relation looks like. It looks like this. It is not a function. It is a relation, but it is not a function. And so it passes through the points 16a and b, -5. So what's the values of a and b? Well, x is 16, so we got y squared equals 16. What values of y go in there? We can sort of think about that. That's our x value. So 4 squared obviously is 16, but this graph, if we drew a little sketch, it reminds us that there's also a negative value. So a equals 4 or -4. Both of those are valid answers for that one. The second one, we've got -5 down here. What's the x value going to be? We've got -5 all squared equals x. -5 squared is 25. So b equals 25. And those are our answers. A equals 4 or -4. B equals 25. Pretty straightforward for that one. Now we've got another relation. You should recognize this form. X minus 1 all squared plus y plus 2 all squared. This is a circle, and the circle's center is going to be 1 in the x-axis and -2 in the y. So this is going to be the center of the circle. Remember, it doesn't follow the same rules for functions being translated. The circle behaves a little bit differently. And what's its radius going to be? We've got this number as 4, but remember that that's the radius squared. So we've got to take the square root of that. It's going to have a radius of 2. So if it's got a radius of 2, that means we've got a circle, and we don't need to draw a perfect circle. In fact, I'll get the circle tool and see if we can do something that looks about right. So I'm going to try and draw a circle with a radius of 4, something like that. Let's see what it looks like. Yeah, that's good enough. Now, if you don't draw a perfect circle, that's fine. You just want to make sure that it is roughly the right sort of thing. Just a sec. Let's see if I can select that circle. There we are. So we want to make sure that it looks about right. So this one is, let's move it up just a little bit more. There we go, that's good enough for what we're doing. So what we can see is that there is a radius of 2 at all sides, which means that we should be able to go 2 in each of these directions to get to the edge of our circle. And that's basically what we need to do. So where we get our marks, recognizing that it's a circle, recognizing where the center is, recognizing that the radius is 2, and that's where you'd get your 3 marks for that one. What feature of the graph indicates that it's a relation rather than a function? We just want to say that it fails the vertical line test. That's all we really need to say for our 1 mark. If you know what the vertical is, we can draw a vertical line. It passes through that at 2 points. This is all you need to say to get full marks. If you say it fails the vertical line test, I'll give you full marks for that because that's what the answer key asks for. If you know what the vertical line test is, then yeah, or if you explain it in some other way, in a more verbose way, I'm fine with that too. But just saying it fails the vertical line test is enough for me. Okay, so that's it. That's the end of term. Now you may have watched this video before the WebEx lesson that we're going to be having on Friday at 9:40. Or you may have watched it after, but either way, we are now going on to holidays. I am going to aim to try to create some tutorial videos and revision videos basically of the first term, just so that we have an idea of everything we've done and we can get off on that on the right foot. And I'm going to be doing some more practice exam questions just to keep us up to speed. Anyway, have a great holiday, and I hope you come back for term 2 all ready to go. Okay, have a good one.